I don't know, but by the end of the next quiz, you would have seen both possibilities. So, okay. Look, guys, there was definitely progress on the quiz, without a doubt. It's not even close, but we're still not where we need to be. We need to clean this up just a little bit. So let's work on this for a second here. Oh, a lot of times it comes. Okay. Now, talks about starting with a square, just like yesterday. And then it says doubling the side and decreasing the other by 1. So that makes this 2x, and that makes this x minus 1. Well, we're looking good on that, right? Yeah. Okay. Now, there were some people who still were using multiple variables, L's and W's. When it comes to quadratics, you can't go multiple variables. You stick with one variable. Okay? Now, the length times the width is equal to the area. Then, what does it say about the area of the square? It says if you increase that area by 15, not by 15%, just by 15. So forget about the extended diagram. What was the area of the original square? Original square, here it is. What's the area?
15.
How do you find the area of a square?
Length times width.
Good, what's the length? Come on, talk to me, what's the length? Look, x. What's the width?
X.
What's x times x?
X squared.
And it's 15 more than that.
So if it's percent, you don't add.
If it's percent, then you gotta go into that 1.25 or 1.15.
That was really dumb.
In all honesty, what I saw out of it was like, you tried to be a great kid, and you tried as hard as you could to understand the question yesterday, but you got so robotic about what that question did that you didn't consider just reading the question first, and that it might be slightly different. So the reason I did that on the first one, percentage, because that was a really dirty, rotten, terrible thing that they did. And then today, this is more normal. This is a normal, very difficult question. This is fair game as far as I'm concerned. And this is how it usually looks when they give you a really hard one.
I think for the last question, part 3.
4.
Part 4.
So, I think this is pretty typical, and I think you'll find it's a lot easier than yesterday's. Distribute. Get it all on one side. Oh, this was plus, so this becomes minus. Oh, I put it plus, so that should be minus. And I get x squared minus 2x minus 15 equals 0. I think you can already see it's going to get a lot easier. Yep.
Why did everything turn into a negative?
Well, I'm subtracting the x squared, and I'm subtracting the 15 to get it all on one side. Remember, with a quadratic, you want everything on one side.
Oh,
So 2x squared minus x squared is x squared minus 2x minus 15. Factoring it, I get x minus 5 times x plus 3 is 0. Maybe it's the guy on the left, maybe it's the guy on the right. Add 5 to both sides, x is 5. Subtract 3 from both sides, x is negative 3. That's impossible, reject it. 5 seems to be, at this point, what we're going to work with. Now, the original rectangle is going to be 5 times 5, or the original square, I'm sorry, is 25. And the other one would be 2 times 5 is 10, and 5 minus 1 is 4, and 10 times 4 is 40. 40 is what they want. They want that second area. But the reason I did both of them is, can't you now see that the 40 is 15 more than the 25?
Mm-hmm.
All right, so that's your correct solution. Okay? So what I would suggest for the weekend is I would definitely do this tonight. I would take 5 minutes to look over the quiz and the quiz from yesterday, because you don't know if it's going to be a percent or just a simple, straightforward 15 more. Then I would do that again Saturday and again Sunday, and I think you'll be fine on Monday. Yes?
With the percent one, like the only difference is in the beginning you add a 1 to it,
Well, if it says it's gonna increase by a certain percent, then it's gonna be 1 point whatever, 15, 25, 35.
Multiplied by 100.
Yeah, and then you're gonna have to subtract it just like here, and then get that, and then multiply by whatever it takes to get 1x squared. Okay? Or at least a whole number x squared. You can't go with, well, you could go with a fraction or a decimal, but that gets really difficult. All right? Okay, are we good? All right. What I look at, the work we've done the last 2 days on this is like peeling layers of an onion. If the understanding is deep, deep, deep inside that onion, the first layer, and we often think we have it. How many times have you taken particularly a math test, and you think you have it aced, and you get the test back, and you get a grade that's a little worse, or sometimes significantly worse than you thought you were gonna get? And it's because a lot of times people believe when they see one variation of a question, they understand it all. But what they don't understand is they haven't seen multiple variations of a question. And until you've seen pretty much every variation that they can come up with, you really don't understand it all. So this is a second variation, okay? This is the common variation. This is the one that you should expect to see most. The percent one was an out there variation, okay? All right, so I think, does everybody agree that today's was easier than yesterday's? Okay, so work on it. I'm very confident that you'll be in good shape. Okay, so let's take a look at what we have going on here. I haven't even looked at this sheet in a few days. About a year ago, Joey watched online video game ban. Noticed it had been viewed only 843 times. 1 month later, Joey noticed the band's video had 1,708 views. Joey made the table below to keep track of the cumulative number of views the video was getting online. Okay. It says write a regression equation that best models this data. Okay, so what do you need to do when it says write a regression equation?
Right.
Yeah, but how do you do that? What?
Put it in, go to stat,
That's right.
and I'll do it as
Stat edit L1, L2, right?
a, no, what? Yeah, yeah. And then you put in your x and your y,
Mm-hmm.
and then you go back to stat,
Mm-hmm.
go to calc,
Right,
then go down to the floor where it says line regression, A
Right.
is supposed to be,
right.
hit enter twice,
Mm-hmm. And what'd you get?
9,
A equal to B. What was A?
A equals 9,123.4.
9,123.4, okay.
It would be 4.42 something, but it would
Okay.
round, okay.
And then B is?
Negative 10,723.
All right, so here's the deal.
0.6.
Let's see if this makes any sense. What do you notice about these numbers?
You're going up.
They're doubling, right? If something's doubling, is it linear?
No.
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 Let's go back to stat calc. There's also an exponential regression. As one of the choices.
Wouldn't that be 8?
What does 8 say?
Line regression A plus BX?
No, let me see what you think it says.
AX plus B.
Oh, I see it. It says exponential
Yeah.
regression.
It's number 10 at the bottom.
Enter.
Yeah. Unfortunately, you don't have the two lists in there, I think.
What says quit? Mismatch.
Yeah, you gotta have all the data in for L1 and for L2. But this is clearly going to be exponential because I notice everything's doubling. That's a geometric sequence. So if you tried to do something linear with this, you would have a little bit of a problem because the graph kind of looks like this. Is that linear? No.
Wait, what do you put for the 2?
Well, once you get your equation, okay, this equation will look like this. You know how geometric or exponential is y equals a times b to the x? They will again give you an a and a b. And let's just say, for argument's sake, that a is 840. Let's just say it. It's going to be close to that. And let's say that b is 2.1. And then you want to do month 2. You just do 840 times 2.1 to the second. So it's the same exact idea as linear, except they're going to give you an exponential function. Okay?
So for number 2, when you put it in your calculator, what would you put?
I would whatever they give me for A and B, I would write y equals, and I would do 840 times 2.1 up arrow 2.
No, it says forgot to record.
Yeah, but it's the second one, so that means the x is 2. So you put in a 2 here, you plug it into the formula, and that's what you're gonna put down. As a predicted value. It's not necessarily the exact value, but it's a predicted value of what you're
So
expected.
for y, you'd put,
You don't put anything for y. You're gonna calculate y by putting in x. See, they gave you the x. Here's the x, it's 2. Now, if they give you the formula, which they will give you an a and a b. And once you get the a and the b, you plug in 2 for x, and you have your answer.
that's wrong, cause I put.
Right,
0
you did linear.
Oh.
Correct, yeah. Linear, definitely wrong, because it's not a linear progression. If it went 800, 1700, skip it, 3300, then it looks like you're going up by 800s at a shot, and then you definitely go with linear, okay? I hope you're seeing and sensing on your work that factoring is an extremely important skill on this Regents exam. And what we're really looking for you to be able to do is to find common factors. What's the greatest common factor here? 2. So that's 2 times n squared minus 6n minus 16, which would be 2 times n minus 8 times n plus 2. Some of the mistakes that we encounter during the year is people would forget the 2. They do it on the first step, but they forget to include it in the answer. Make sure that you include that 2 in the answer. The entire thing must be written, otherwise you will not get credit. Okay? And as far as the last one goes, unfortunately, sometimes if I switch, if I switch versions of Word and I go from a newer version to a later version, sometimes the later version doesn't recognize the work of the newer version. So every once in a while I get one of these little boxes in there, particularly if I used an equation editor to do this. So let me just get a tip of my 5, and then I will answer this question. So, what does it say on your paper?
2x plus 1 absolute value, and then plus
Oh, absolute value of 2x plus 1. Okay, good. This is today's lesson. All right, did you? What do you think the answer is? -4.
I got 3.
It's both.
Okay.
All right, that's the hard part about absolute value. What does absolute value mean, guys?
Distance to 0.
Distance from 0. So if I have some absolute value equaling 7, this is 0 on the number line. If this is going to be -7 and this is 7, aren't those both 7 units away from 0? So that means what's in here, 2x plus 1, it could be 7, or the 2x plus 1 could be -7. They both work. So when you get an absolute value equation, you have to split it apart. One of them could be the positive, and one of them could be the negative. Then you just solve them, which is obviously very simple. 2x is 6 divided by 2. X is 3, minus the 1, 2x is -8, divided by 2, x is -4. So those are my 2 answers. And that's the big revelation with absolute value, is there are 2 answers. Let's look at this graphically for a second and try to understand this graphically. If I did a graph of 2x plus 1, it would look something like this. Okay, absolute value graph. Don't absolute value graphs always make a V? Okay. And then it equals 7. So the graph of equaling 7 goes this way. So do you see how it's going to touch in 2 places?
Yeah.
So that means that there are going to be 2 solutions. Wherever the graphs overlap is a solution. You did it with 2 lines and they only overlapped once, but when we get into something like a parabola or something like a graph of a line, then it can definitely intersect twice. It's not limited to once because both parabolas and absolute values turn around, so you could touch twice on both of them. Okay? All right, so why don't you try the next one? What is that? Absolute 3x minus 4 equals 9?
Yeah.
Yeah, give that a shot. Let's see what you get. Question?
9 plus 4 doesn't equal 14, Erica.
Oh, it's 13, sorry. Call that a mental spasm. I'm very good at those. All right, so we get negative 5/3 and 13 over 3?
Yeah, or we're supposed to get this.
What was that?
Okay, never mind.
Are we comfortable with that? Does everybody understand the idea of splitting it? One side's negative, one side's positive, because it can be either side of 0? Make sense?
Yeah.
Okay. By the way, just because the distance could be positive or negative, the distance from 0, does not mean the answers both have to be negative or both have to be positive or one of each. All right? The answer you come up with is just what you plug into it to check. All right? The fact that it can be either side of 0, all that means is I'm going to start with one is negative 9 and one is positive 9. That's all it means. After that, whatever the equations give me is whatever the equations give me. Try the next one. And is that absolute 4h plus 11 equals 9?
Yeah.
Dude, I did it a different way.
What was your different way?
Look. When I do it like this, but I make it opposite before I do it
You make what opposite? In the bracket or outside?
in it. And then it's
If you
like
do that in the bracket, it is possible to do. The problem is that you then have to negate them both, and you have to keep the 9 the same. So I just think it's easier, you have to negate one side or the other. I think it's easier to negate the 9 than to negate what's in the package. Okay? Any questions? Negative 5 and negative 1/2 are the two answers. Are we good?
Yeah.
Okay, do the last one. Warning, Will Rogers, this is a dangerous one. Think about that. The fact that Liv is in that seat gives me core exercise while we're working on this. Why is there no solution? Maya?
So both negative fractions.
Nope. That's not why. Why?
Is it because if you do 7 times negative 1, 7, and then subtract by 2, you wouldn't get negative 3?
Well, yeah, it wouldn't check. I think that's what you're trying to say.
Yeah.
It would not check. Why specifically would it not check? Andre?
Because you can't have an absolute value that equals a negative.
That's right. Since when does an absolute value come out to be a negative? So we have our process where we make it, maybe it's the positive, maybe it's the negative. But we do have to think about our answer a little bit, because absolute value, when I do an absolute value function, the output always has to be a positive number. This is negative. Since when can I be negative 3 units from 0? Can't. So you gotta think that through, and you gotta understand that. Does that make sense to everybody?
Yeah.
All right, Sid, we okay on that? Okay. All right, it's homework time. Please please put calculators back. Every day I've been finding calculators laying around the room. Very uncool.